Look up. On a clear night, away from the glare of city lights, you can see it, a tiny reddish point of light wandering against the tapestry of fixed stars. That is Mars. For millennia it has captured our imagination, a celestial campfire around which we have told our greatest stories. Of gods. Of war. Of worlds beyond our own. This persistent dot in our sky has whispered to us across the vast silent gulf of space. It has dared us to wonder, to dream, and ultimately to reach out and touch another world. It is a dream woven into the very fabric of our species, a pull towards the unknown that is as old as consciousness itself. This ancient dream is not just a fantasy, it is an expression of our most fundamental nature. We are explorers. Our ancestors walked out of Africa, crossing continents and oceans. They looked at the horizon and saw not an end, but a beginning. Why Mars? Among all the worlds in our solar system, why does this planet hold such a magnetic pull? The answer lies in its tantalizing familiarity. Mars is the most Earth-like planet we know. It has a day only about 40 minutes longer than ours. Polar ice caps that grow and shrink with the seasons. Weather, winds, vast dry riverbeds that tell of a distant watery past. A world that might have once been a cradle for life. Today its atmosphere is thin. Today its surface is cold. But its soil and frozen ice caps hide the resources we'd need to survive. Water ice that can be melted for drinking. Water that can be split into hydrogen for fuel, and into oxygen for breathing. Carbon dioxide in the air could help grow plants in protected habitats. Mars is not a paradise. It's a world of possibilities, a fixer-upper on the edge of our capabilities. The quest for Mars is a quest for answers. Are we alone in the universe? Finding even the simplest microbial fossil would reshape our place in the cosmos. To get to Mars, we must first learn to live and work in deep space, and for that, we are going back to the moon. This is the goal of the Artemis program. It is named after the twin sister of Apollo, and its mission is not just to revisit the moon, but to stay. Artemis is about building a permanent human presence on and around our nearest celestial neighbor. We will build a lunar base. We will establish a small space station in orbit around the moon called the Gateway. This will be our training ground, our deep space outpost, our dress rehearsal for the great voyage to Mars. The Artemis missions will land the first woman and the first person of color on the lunar surface. This is more than a symbolic gesture. It signifies that space exploration is an endeavor for all of humanity. The astronauts of the Artemis generation will be pioneers in the truest sense. The journey to Mars requires a new generation of cosmic vehicles. They are taking shape in our factories and on our launch pads right now. The centerpiece of this effort is NASA's mighty space launch system, the SLS rocket. This is not just an incremental improvement on past designs, it is a monumental leap in capability. It stands taller than the Statue of Liberty and generates more thrust at liftoff than dozens of jumbo jets. Paired with this powerful rocket is the Orion spacecraft, a marvel of modern engineering designed for the rigors of deep space. Orion is a capsule, but it is a world away from the cramped quarters of the Apollo era. It is built to sustain a crew of 4 astronauts for weeks at a time. Its heat shield is the largest of its kind ever built, designed to withstand scorching re-entry at speeds of up to 25,000 miles per hour. But the SLS and Orion are just the beginning. The architecture for a Mars mission is a complex dance of multiple components. We will need advanced landers to safely touch down on the Martian surface. We will need surface habitats where astronauts can live and work for months or even years. And we will need ascent vehicles to lift the crew off of Mars for the long journey back to Earth. This new era of space hardware is also being driven by a revolution in commercial spaceflight. Companies like SpaceX are developing their own reusable rockets and spacecraft like the Starship, which are designed from the ground up with Mars in mind. Sending rockets and robots to space is one thing. Sending fragile human beings is another matter entirely. The astronauts who will make the first journey to Mars will face challenges unlike any faced by explorers before them. The journey to Mars will take 7 to 9 months each way, during which they will live in a state of weightlessness. This environment takes a toll on the human body, causing muscles to atrophy and bones to lose density. Astronauts on the International Space Station spend hours every day exercising on specially designed equipment to counteract these effects, and the Mars crew will do the same. They will train in underwater laboratories like the Nemo habitat off the coast of Florida, which simulates the microgravity environment and allows them to practice complex tasks. The psychological challenges may be even greater than the physical ones. Imagine being confined in a small space with the same 3 people for nearly 2 years. The Earth is no longer a comforting blue marble in your window, but a distant, fading point of light. Communication with home will have a time delay of up to 22 minutes each way, making real-time conversation impossible. NASA conducts long-duration isolation experiments like the Hera and Chapea, where crews live in simulated Martian habitats on Earth. Beyond physical and mental fitness, these astronauts must be masters of a dozen different trades. They will be scientists, engineers, mechanics, doctors. When something breaks millions of miles from home, there is no calling a repair service. They must be able to fix their own spacecraft, operate complex scientific instruments, and handle any medical emergencies that arise. Before we send humans to Mars, we send our robotic emissaries. These rovers, landers, and orbiters are the scouts, the trailblazers who pave the way for human explorers. They are our eyes, our ears, and our hands on the red planet, gathering the critical data we need to make the human journey possible and safe. For decades, a fleet of these explorers has painted a clearer picture of Mars. They have mapped its surface, analyzed its atmosphere, drilled into its soil, revealing a world of stunning complexity. On the surface, rovers like Curiosity and Perseverance are our field geologists. They are mobile science laboratories, equipped with sophisticated instruments. They can drill into rocks, zap them with lasers to analyze composition, and search for telltale signs of ancient organic molecules. Perseverance deployed the Ingenuity helicopter, proving powered flight is possible in Mars's thin atmosphere. Perseverance also began collecting and caching rock samples, which future missions will return to Earth for laboratory study. The MOXIE experiment aboard Perseverance demonstrated producing oxygen from Mars' CO2. That's a game-changing technology. It means future astronauts could generate breathable air and the oxidizer needed for rocket fuel. The greatest challenge of a human mission to Mars can be summed up in one word: distance. Mars is far, unimaginably far. At its closest, it is about 34 million miles away, but that distance can swell to over 250 million miles when the two planets are on opposite sides of the Sun. A one-way trip, with our current propulsion technology, will take between 7 and 9 months. One of the most serious dangers during that long transit is radiation. Outside of Earth's protective magnetic field, space is filled with a constant shower of high-energy particles from the Sun and from distant cosmic rays. Long-term exposure to this radiation can damage DNA. It can increase the risk of cancer. It can cause a host of other health problems. The Orion spacecraft is being built with advanced shielding. Mission planners are developing strategies to protect the crew, such as creating a storm shelter in the most heavily shielded part of the ship. Then there is the sheer logistical complexity of supporting human life for so long, so far from home. The mission will last for nearly 2 years. The trip there, the stay on Mars, and the trip back. The crew must bring everything they need with them: air, water, food, spare parts, or they must be able to produce it themselves. Every system must be incredibly reliable and redundant, because there is no resupply mission. And finally, there is the challenge of landing on Mars and, even more difficult, leaving it. Mars has a thin atmosphere, thick enough to create friction and heat during entry, but too thin to be of much help in slowing down a heavy human lander. The monumental effort to reach Mars is not just about what we will find on another planet. It is also about what we create here on Earth. The pursuit of space exploration has always been a powerful engine of technological innovation and economic growth. The technologies developed for the Apollo program gave us everything from cordless power tools, freeze-dried food, to integrated circuits that power our modern computers and smartphones. To keep astronauts healthy on a 2-year mission, we need to develop advanced medical monitoring systems, new forms of telemedicine, more efficient ways to diagnose and treat illnesses remotely. These innovations will find their way into our hospitals and clinics. To grow food on Mars, we need to perfect high-yield, closed-loop agriculture systems that recycle every drop of water and nutrient. These techniques can help us address food and water scarcity in a changing climate. The push for Mars also inspires a new generation to pursue careers in science, technology, engineering, mathematics. The excitement of a grand, tangible goal like landing humans on another planet is a powerful motivator. The jobs created by the space program are not just for astronauts and rocket scientists. They are for welders, software developers, technicians, thousands of others across a vast supply chain, driving economic activity and pushing the frontiers of manufacturing. Ultimately, the journey to Mars gives us something even more valuable than new gadgets or a stronger economy. It gives us perspective. From the vantage point of Mars, Earth is just a pale blue dot, a fragile, beautiful oasis in the vastness of space. The images sent back by our explorers remind us of our shared home and our common destiny. This cosmic perspective has the power to unite us, to help us see past our petty divisions and work together to protect the only home we have ever known. The dream of Mars is, at its heart, a dream about the future. It is a vision of humanity not as a species confined to one world, but as a cosmic traveler, a bearer of life and consciousness venturing into the solar system and beyond. Setting foot on Mars will be a moment of transformation, a turning point as profound as when our ancestors first learned to control fire or build cities. This journey will redefine what it means to be human. The first generation of Martians will be pioneers of a new branch of human society, forged in a completely different environment. Bound to Earth by history and biology, their experiences will be entirely new. How will their culture evolve? What art, what music, what stories, inspired by red landscapes and two tiny moons? The settlement of Mars will be a grand experiment in sociology and humanity, a chance to build a new world, learning from the mistakes of our past. The inspiration will ripple through generations. Like Apollo inspired millions to look up at the moon, the first footprints on Mars will ignite imaginations across the globe. It will be a testament to what we can achieve when we are at our best, curious, collaborative, and courageous. It will tell every child that the grandest dreams are attainable, that the universe is to be explored, not feared. A beacon of hope, a symbol of a future guided by curiosity, not conflict. We stand today on the cusp of this new era. Rockets are being built, astronauts are training, robots are scouting the way. We will witness humanity's shift from one planet to many. Our story is not confined to this world. It will be written across the solar system, dusty plains of Mars, moons of Jupiter, moons of Saturn. We are stardust, and to the stars we are returning. The journey to Mars is not an end, but a beginning, our next great step into the cosmic arena.